Name is Divya P. AAT1 Analytical Instruments. So my topic is calibration curve types and data interpretation. Calibration. What is calibration? Calibration is the process of comparing a measuring instrumental reading against the more than the standard, and the error in the device involves adjustment in the screw gauge or gauge with the standards and between measurement critical the quantity and safety across industry. For example, engineers or science, a thermometer in the calibrate to confirm its reading 100 degree Celsius in boiling water. In industries, a pressure gauge is the check between a measuring pressure on producing line. So human reservoir between the applied or performance standards. Calibration curve. A calibration curve or standard curve is the fundamental graphical tool in analytical used to determine the concentration of unknown sample by the comparing its instrumental response, like example absorbance and peak area, to set the standard sample of unknown concentration. So calibration curve. The calibration the analytical between chemistry and the biochemistry to required unknown between a disavowed limits. So construction created by the measuring several standard sample known concentration and plotting the resultant data to required linear, and y is equal to the formula is y is equal to mx plus c. So for food safeties and the environmental and pollution, like etc. So in the types of equation, the polymer used to a power equation to map the relationship. In a basic calibration curve, so x-axis is concentration and y-axis is instrumental signal y. So blue dot is known concentration, and line registered between y is equal to mx plus c, and into is unknown sample. Calibration curve. The principle of calibration curve is based on the direct relationship between the analytical concentration and the instrumental response. So, standard solution of unknown concentration are prepared and measured. The principle showed is the instrumental response the concentration between within a critical range along with concentration to be determined from the calibrated curve. A common equation display on the graph is y is equal to mx plus c, where y is equal to instrumental response, x is equal to concentration, m is equal to slope, and c is equal to intersect. So in here the x-axis is equal to concentration and y-axis is interpressor. So m is equal to slope. So the formula is y is equal to mx plus c. Calibrations. Need of calibration. Instrumental generates signals of the electrical signal. If we can unknown sample, the sample from the must be a compared with signal and of a standard. This compared the mathematical in nature. The signal is linear proportional to a concentration of taken in the sample. So y absorbance is equal to mx concentration plus c. So this equation is written using standard. So in graph, so x-axis is equal to concentration and y-axis is equal to signal. So the curve will be in 0 to the raise of the constant level. So it will be the increasing and the the constant will be there. So LOD and LOQ, LOL, and some slope in the sensitivity and the noise. Calibration curve. So a linear calibration curve shows the straight line relationship between concentration and response if follows the equation y is equal to mx plus c, where m is the slope and c is the intersect line curve, and the easy to enter commonly used in routine laboratory analytic. So plotting data absorbance and the instrument response in placed in the y axis and concentration in placed in the x axis. The 5 points the curve between r square value which the closely involve the data points and the calculation straight line. In graph we can see the x-axis is concentration and y-axis is the instrument respond absorbance. So standards in will be the red dot and data points. So blue line be the best line fit. Y is equal to 0.098 x plus 0.02. So r square will be a constant, so 0.9960. So this graph is linear calibration curve. Linear calibration curve. A non-linear calibration curve is used when the instrumental response does not change at the constant rate and between the concentration of on the due to a station of the chemistry instruction. The standard effect, a non-linear of the effect, high concentration were the determined between the standard and can be long provided between a response. So next is increasing data. So using 7 points, this non-linear calibration curve is 7 points. So either than 3 or 5 provides the necessary response between the minimized and concentration error. So in graph we can see, so x axis is equal to concentration, so y axis is equal to instrumental response. So 7 standard points will be there, and the blue line is non-linear. So non-linear calibration curve, so coming in 0 to the so increasing value between a constant. So this graph is non-linear calibration curve. Standard calibration method. In the external standard method, a standard solution are the spread between a sample. The unknown concentration is determined by the comparing the sample response with the standard calibration curve. They are used to a calibrate instrument. Take series of sample of unknown concentration, though there will be a 5 concentration will be there and 1 will be a unknown concentration. Take unknown concentration, then response signal absorbance, then the peak area, the concentration between a it will absorb. So non-response signal to obtain for unknown concentration sample of analytical concentration. So next will be a diagram of external standard calibration method with graph. Standard calibration method. So in here low concentration, so 1 C1 will be a low concentration method, C2 and C3, C4 and C5 will be a increasing concentration. So in here the one is will be a unknown sample. So measuring absorbance, we can see the sample between 0.6 to 0. So by step we are preparing a standard solution with the known concentration. So next will be a measuring absorbance with the standards. So plot calibration curve with absorbance and the concentration. So measure absorbance in a unknown concentration sample to determine the constant calibration curve. So in graph we can see the x-axis is equal to concentration and y-axis is equal to absorbance. So here the 5 points will be the calibration curve, so standard. So this diagrams and the graph will be a external standard calibration method. Next one is the internal standard calibration method. So in here this method is generally used for calibration of liquid chromatography. So it accounts the routine between the response of chromatography system, a system in adding a constant amount of all samples. So added substance is not same as a sample between the products, so added substance do not created with the analytical. So example between a chromatosome, so chromatography between a response between the analytical of the is, so when we can see the single ratio of the cancer out. Internal standard chromatography method, so we can see the concentration of C1, C2, C3, C3, C4 and C5. So next one is CX, that one is the unknown concentration. So we are adding the strong solution internal standard IS stock solution. So 100 ml 100 ml 100 ml we are putting the sample C1 C2 C3 and C4. So the concentration of unknown standard between the sample between the unknown concentration. So we are preparing a series of standard with the known concentration, adding a small amount of internal standard IS solution to all the standard and the unknown samples. So measuring the instrumental response of analytic between internal standard. So we are calculating the response ratio. So internal standard, then the plot the calibration curve response ratio versus analytical concentration. So we are measuring the response ratio between unknown. So determine the analytical concentration of the unknown from the calibration curve. So in here the graph will be x-axis is equal to concentration of analytical, then y-axis is equal to response ratio analytical IS. So in here analytical IS and the CS unknown concentration will be there. So this one is the internal standard calibration method. So next topic is a standard addition method. The standard addition method involves adding the concentration of between direct in the sample. This is method minimum and effect bit. It will improve the samples which in biological fluids, wastewater and food production. So it is useful when the present in the concentration between the ideal blank in available. So the typical pressure between the concentration among between the unknown but the between standard. For example, the 525 ml of volumetrical flask between used to fill the 100 ml of unknown concentration. Then the standard is adding the different amount such as 0 1 2 3 4 4 and 4 ml. So finally each flask must be a mark with the suitable mix well. So the ideal of the production between total concentration and the sum of unknown concentration standard. Standard addition method. So in 1 2 3 4 5, the sample with unknown concentration Cx and the add concentration volume Vx into a series of a flask. So we are adding in a flask increase volume Vs. The Vs is the sample solution concentration of Cs. So the first step is the pipette at the constant volume Vx of the unknown concentration sample in series of flask, and adding increase the known of Vs of the standard solution with concentration Vx. So delay between the flask and same volume of V total with the solvent. So measuring the between each flask. So calculate all the standard concentration. So C add is equal to Cx into Vx divided by V total. So plot a graph. So we will see the graph between next. So make a unknown sample final between V total. The solvent the add a deduction between sample total V total. So only the amount of standard changes between the concentration. So add between the concentration and same between the same concentration level. Oh, we are seeing the standard addition method, the graph. So the plot response between C add. So x-axis is equal to add standard concentration. So Cs into Vs divided by V total. So y-axis is equal to instrumental response signal. So we are seeing the external between the x is equal to intercept is equal to minus C, the concentration of analytical in sample. So Cx is equal to minus x interproduction. One is instrumental response versus concentration graph. So now we are seeing an instrumental response versus concentration graph, calibrated curve in equal tools plotting known a concentration. So x-axis and against that were between a absorbance peak area or height. So y-axis to determine unknown concentration of sample. So next the data point. So red point will be a analytical physical measurement taken by the standard solution using the already between the concentration. So the reagent value blue, this is the cancelled best fit the line. The ideal analytical method of displacement between the instrumental the response increasing at the constant rate at the substance. The equation y is equal to mx plus c. So y is the signal of math given you. So x is equal to concentration of to find the value. So m is equal to sensibility, the step in between the slope of instrumental or more sensitive between the small changes in concentration. So c is the y intercept between the background voice or a signal from a black sample, so zero concentration. In graph we are seeing the concentration is x-axis and the instrumental respond, so absorbance is equal to y-axis. So red is the standard data points and the blue line will be a best fit. Y is equal to 0.10x plus 0.01. So this graph is instrumental response was concentration calibration curve. One is correlation coefficient R square interproduction. So the R square coefficient of determination measured by the production between a determined value like independent variable range from 0 to 1, 0 or 0% to 100%. The height R square in between best fit measuring the explained variable. It is the equation between the moles does not exist. So the interproduction 0.01 to 0.09 small fixed size and 0.09 to 0.05 medium effect size and 0.25 plus a large effect size. One is data interpretation. So data interpretation method between involves the collected information through a quantitative numericals or and the technology to draw and concentration. Key method includes the statement between the mean media such example. So battery between the bar graph, pie charts and the line graph to transfer raw data into inside. So bar graph used to common quantified between a calculated, so pie chart between the part of the whole. So line graph used to between the time period, the plot between the relation quality between the two variable. Heat map used to a data variables. So in graph we are seeing the x is equal to month and the session between the thought the sample treated between line. So the 1 to 2 the will be a increasing or decreasing, increasing and it will be a constant level. LOD and LOQ. So limited detection of LOD and limitation of contribution of LOQ are the key critical chemistry between the part. The lowest amount of analytical used to can be determined or measured. So LOD is the small amount of the data between the background noise, while LOQ is the smallest amount that can be quantified between the result. So we are seeing the difference between LOD and LOQ. The smallest concentration of analytica between the small sample that can be easy to determine to the zero. LOQ, the smallest concentration of an article, the test sample that can determine the axis between the one is advantage and disadvantage. So advantage are the positive benefits which created by the positive such as increase efficiency, cost saving or improving quantity. The limitations of a weakness and consider the whole method back or graded between the scope. So now we are seeing calibration method like advantage, disadvantage. So next one is the direct measurement method. The fast calibration speed, easy operation, no need of calculations. So disadvantage is unable to locate the concept, low acceleration. So standard from the motion method. So advantage is no need of extra equipment, high flexibility available to a calibrate in the real time. The come between the low reliability, the proper method. So advantage is a high accuracy of the single calibration process able to data. Then disadvantage is high time concentration, simple calibration method. So this one is the advantage and disadvantage of calibration curve types and data exception. Is conclusion. So calibration curve is the fundamental tools used to analytical chemistry engineer the data science to determine the unknown concentration or value of the substance by the comparing it to be a set of known concentration. The graphical of mathematical modes gapping instrument response, like example absorbance and the peak area to active. So this one is the topic of calibration curve types and data exception. The conclusion is this. You